My dear friends, welcome back to BSpice. In this session, we'll continue with solar design, wherein we'll focus on PV construction. So this is the look and feel of the construction. As you can see here front, this is your photovoltaic cell, and this is your, the sunlight, okay, hitting it, and this negative electrons and positive holes, okay, and you have this p-type junction silicon and depletion layer. Then you have a n-type silicon, and this is connected to the load. All these, okay, this is a typical construction. And also, as you can see here, this is a n-type and this is your p-type. So n-type is what is electron, right? Yes. Then p-type is hole basically. So hole in the sense positively charged, right? So electron negatively charged, holes are positively charged, right? So maybe I'll touch upon a bit here. N-type and P-type silicon refers to two main types of semiconductor materials used in solar cell. Okay. So in this N-type, actually, friends, in this N-type, uh, design features is a doping element is phosphorus, phosphorus or arsenic. N-type silicon, it is phosphorus or arsenic. So basically, it's a electrons here, negatively charged. See, N-type silicon has an excess of free electron. Here we have excess of free electron, making electrons the majority charged, right? Charge carriers. So this type of silicon is generally more resistant to light-induced degradation and has a longer lifespan. So that is about N-type. Then we have a P-type silicon. See, the doping element here is boron or gallium, okay? And charge carriers is hole actually. Hole means positively charged. So the P-type silicon has a deficit of electron, okay? Resulting in more holes, meaning positive charge, right? So where electrons could exist, okay? Where electrons could exist. So this type is commonly used in the solar industry due to its lowest cost and simpler manufacturing process. So basically how this works, these two types of silicon are combined to form of a p-n junction, right? So when sunlight, hits the solar cell, okay, then it energizes the electrons in the n-type layer. It energizes the electron in the n-type layer, causing them to flow towards the p-type layer. So this movement of electrons generates an electric current, okay, which can be harnessed for power. So that is how the whole things are working, friends. Now let us go into the details. Okay, PV construction, cell construction. Simple PV system consists of solar panel, okay, which converts the sunlight to DC electricity. Okay, then battery bank or charged by the charge controller, which is supplied from solar panels, right? Then this inverter converts the DC power to AC power for utilization. That's it, friends. Very simple. This is how the whole design. Okay, now again, construction, right? Yes. So what is this? Construction of PV cells. Construction of PV cells. So that is what I explained in the beginning. I repeat one more time, nevertheless, no issues. See, N-type silicon has a excess amount of electron. It's excess amount of electron, but P-type has excess amount of holes, meaning positive charge. Okay, this is negative charge. So when a light falls on the N-type, the electron gains the amount of energy enough to move from N-type to the P-type. Okay. So electrons go from N-type to P-type to fill the holes. There is a positively charge which causes the flow of current. Okay. So that is the whole phenomena, friends. Okay. Very simple, isn't it? Yes. So now we'll talk about something here. When we connect the solar cell in series, like this, series, right? Like this. Okay. So PV cells are in series, meaning it increases the total voltage. So this is your graph. You see here, friends, current voltage. So current is same, okay, same current, but increases the total voltage. Okay, when you connect two solar cells in series, PV cells in series, current remains same, but the voltage double. Okay, 0.6 to 1.2 volt. Okay, that's about the series when you connect. So when we connect in parallel, you see here, when you connect in parallel, increases the total current. So the voltage remains same, but the current double. So that is the thing, friends. This is the design feature. Okay. So that's all I want to highlight here. But there are many more coming up. So the complete solar design. If you go through this, I intend to do it in parts. Actually, some around 10 parts. So if you go through this, you'll be a master. That's for sure. Okay. Thanks for supporting, and yeah, keep supporting, friends. Your support is very much important for us. Thank you. Take care. See you soon in the other video.